Vision is much more than the image formation in our eye, but there's a substantial part of visual processing in our brain.
The results from this study are quite exciting.
The research conducted is highly relevant to understand our brand new ZEISS ClearMind lens portfolio.
Cognitive load is basically the amount of effort that our active working memory has to exert to solve a certain problem. In other words, how much do we have to concentrate on a certain task? And for this study, we were wondering, can we somehow measure objectively that this cognitive load is influenced by vision? So we know from reports, for example, from presbyopes, that tasks subjectively feel harder. And cognitive load might be one possibility to quantify this objectively. So if compromised vision leads to higher cognitive load, this means that in our everyday life we might become more disorganized, which ultimately affects our well-being. There are typical changes in the electrical signal in our brain that are measured by EEG that can be associated with an increase of cognitive load.
So far, we did not see any evidence of this being studied in an objective measure of EEG. And the research question that was open was, how do we see if uncompromised vision performance can lead to a decrease or increase in cognitive load for different blur levels, for different lens designs, for example. In this experiment, the participants had to do a visuomotor task where they basically had to pick beads from one side and place them on the other while their vision was compromised. What we did for this was basically we asked them to answer a subjective questionnaire like the TLX, which is used in vision quite often. On the other hand, we were also measuring EEG signals from the brain to see how the vision actually impacts cognitive load. The results from this study are quite exciting. What we saw is that when we have blurry vision, we have a higher cognitive load when we perform a task. And this means that the brain needs to put more effort and has a higher cognitive load when the vision is unsharp. The broader context here states that we now try to fill in a gap which existed about how vision and cognitive load or brain functioning is interrelated, and we try to figure out how the dynamic interplay between the two could help us understand how we design better lenses, for example.
The research conducted provides the scientific evidence that blurred or uncorrected vision impact cognitive load, which ultimately makes our everyday challenges, our ability to concentrate on tasks or staying focused, more challenging. Our ZEISS ClearMind lenses are built on an innovative technology that we use to reduce the blur in relevant areas for all-day lens usage. By that, we make sure that the eye is exposed to blur as little as possible. This was supported by the results of a large consumer acceptance test we conducted in different countries. The results showed that 76% of consumers stated that ZEISS ClearMind lenses increase their ability to stay concentrated on tasks, whereas 75% reported that it made it easier for them to stay focused.